Hi, welcome back, IntroStat student. So we are into a new unit, right? And this unit is confidence interval. So the last exercise that I did was finding the critical value, the Z star, right, for the desired confidence level. And so today we're just diving straight into calculating a Z interval, right? Z interval for a proportion. Okay, so before we start, let's talk about what the Z interval does. Okay, so here we are supposed to find a 90% confidence interval. So we are confidence interval is used to estimate the true population, in this case, the true population proportion. It could be a true population mean, it could be a true population proportion, but in this case, it's proportion, right? And we don't have the ability to sample everything. We do not have the ability to sample the whole population, and therefore, we need a sample. And therefore, we have a sample proportion, right? Sample proportion. And to find the confidence interval, there's a formula. It's p hat, which is the sample proportion, plus minus the z star, which is the critical value based on this 95% confidence level, times it by p hat times 1 minus p hat divided by n. So this is the actual formula for confidence interval. And the reason why we're not using P is because we don't know P. So what is P again? P is from your population, right? This is your true population proportion. And we don't know that. That's a question mark. But what we do know is that we have a sample, right? The sample comes from statistics, right? So population, and actually what I should have used is not where I should have just used sample. Okay, sample comes from population, and here this is the parameter, right, which is population proportion, and p hat, which is the statistics, right? P hat is the statistics coming from the sample, which is p hat, sample proportion. So once you understand that, then we can put everything together, because if you look at the formula, the options here, they want you to express the confidence interval in terms of the actual formula. So you just have to plug values in. So here sample is 200, so n is 200. Okay, and then 12 computers have the defect, right? 12 computers have the defect. um, So if let's look at the formula that we have, look at the options that we have. So A, B, C, and D. So you see how A and B, 12 is here, right? And yeah, in fact, 12 of the computers have the defect. But 12 is a number. It's not a proportion. Remember our formula was P hat, right? P hat plus minus z star times the standard times the um, times square root of p hat times 1 minus p hat divided by n. By the way, this is your critical value, which I've already gone through from our last video, and this is your sample proportion, which we call it the point estimate, right? We call this the point estimate. Now this part here we call standard error, right? Standard error, which is the standard deviation of the sampling proportion. Okay, so this one is your critical value. Critical. I don't know how to spell critical value. Okay, Now, this whole thing after the plus or minus sign, this is what we call the MOE, the margin of error, right? This is the margin of error. So, right, let's take a look at what we need to put. So the sample is 200, and out of that, 12 computers have the defect. So the sample proportion will be 12 divided by 200, which is 0.06. So it's either C or D because this is the point estimate, right? Point estimate, the p hat. So if I were to write the formula, I do not mind writing again. And then square root of p hat times 1 minus p hat divided by n. So both have 0.06, right? P hat, because here our p hat is 0.06. So 0.06 plus minus, now z star, I'm going to talk about how to find z star in a second. So z star times the square root of 0.06. Oh, both have the same. See, both have the same standard deviation, standard error, which is correct. 0.06 times 1 minus 0.06, which is 0.94, right? And divided by the sample size is 200. So now the only thing we need to determine is z star, okay? And z star in this case, we are looking at 95%, right? 95% confidence. So if I were to draw 95%, so if this is 95% interval, right, it has to be symmetric. So this is going to be 0.25 because 95% is 0.95. So that means this and the tail, when you add those two tail up, it should be 0.5. And then half of 0.5, which is 0.25. Okay, so this is where your z star is. This is negative z star, this is z star. So to find z star, we have to go to inverse norm, right? Because this is a normal distribution. And we need to put the area to the left, meaning this part here, area to the left. So here is 0.95 plus this little portion here. This area is actually, it's not 0.25, is it? 0.05. So I actually made a mistake, 0.025. So here is 0.025. So my bad. So 0.95, right? The area on the tail end, the sum of those should be 0.05. And then if you divide by 2, each tail should be 0.025. And then I add this and this will be 0.975. Okay? So if I would put this on the calculator, 0.975. So go to second vars, inverse norm, the error is 0.975. I want to find the z star, the critical value. And here the mean is 0, standard deviation is 1.95. So, ladies and gentlemen, it's either C or D. I found that the z star is 1.96, which is right here. So the answer is C. Okay. All right. Actually, did I even go through the question? Oh, my God. I probably didn't read the question. Huh. Anyway, let's read the question. My bad. A political pollster wants to know what proportion of voters are planning to vote for the incumbent candidate in an upcoming election. Now, confidence interval is always in play when you come to election, right? Because we don't know the true population proportion of voters are. And the only way we can come up with any kind of guess, is that, okay, we do a sample and we use that sample to try to estimate what the true population vote proportion is. So in this case, a poll of 150 randomly selected voters is taken from the more than 2,000 voters. And 78 of those selected plan to vote for the incumbent candidate. By the way, 2,000 voters in the population. What is 10% of 2,000? 10%, well, it's 6.1 multiplied by 2,000, right? 200. So as long as my sample size is less than 200, the independence rule, right, is satisfied. So 200, and we only sample 150. So, and 78 out of the 150 people sampled, the voters sampled, actually plan to vote for the incumbent candidate. Now, I can do a long way to solve this, but instead, I'll do a quicker way. So let's clear the screen. Now, if you go to stat, now this is a function on the stats calculator that you can use to find confidence interval. And then you go to test, okay? So, and then from the test, now because this is a z interval, right? And you're using one proportion. So we are going to one sample, one proportion z interval. Okay? We're using one proportion z interval. So press enter. So they ask you, out of the x, how many? 78, right? 78. And what's the sample size? 150. And what is the confidence level? 90%. So I can put 90 here. Ladies and gentlemen, look, that's it. That's your confidence interval. So your confidence interval is between 0.4529 and 0.5871. Right? So this is your confidence interval, which incidentally, if you look at the option here, I might have to come back to this 0.45. Well, actually, I have it on the screen already. So what is interesting is if you look at A, B, C, and D, if you take this 0.52 minus 0.067, so 0.52 minus 0.067, is it 0.432? Well, I need to actually see if that's correct. And then take 0.52 plus 0.067, so 0.587. So what was the answer that I got? We go down to one prop z int, 78. Okay, so the answer is 0.453 and 0.587. See, 0.453 and 0.587. So C is the answer, right? So here the answer has been calculated, and they simplify for you. So you could have easily used this plus p hat plus minus z star times square root of p hat times 1 minus p hat divided by n. And you can work this out to see if it equals to this, and this, it's going to be 78 out of 150, right? It's going to be 0.52. So hopefully that makes sense. Okay, so maybe let me do another one. Okay, so the answer now here, they're all in confidence interval notation, which we can easily just go through the question. A survey of 400 randomly selected homes from a large city with over 30,000 homes. So, point one, 10% of 30,000. Let's see if the so as long as the sample doesn't get more than 3,000, we're good. But here the sample is only 400, so we're good. That shows 16 of the sample homes didn't have a television. Based on this sample, which of the following is a 95% confidence interval for the proportion of homes? So all I have to do is go to stat, test, and then go to one prop Z interval A, right? And then how many? It says 16, right? 16 out of 400. And then confidence level is 95. So 0.02, let's see if it matches any of the answers here. 0.021 and 0.059. Okay, so you can use this calculator function to help you, do it, solve the question. Okay, so if you have any question, let me know. Thank you very much.